Assalamu alaikum dear students. Today we are going to discuss another conic section which is parabola. You know that the parabola is the conic section geometrically. It is a conic section obtained the when this plane intersects the right circular cone at an angle which is equals to the angle of this right circular cone. Now we will define this parabola analytically, and we will derive the standard equations of this parabola. A parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point. This fixed point should not be on the fixed line in the plane. That is, if we consider a fixed line, this is the fixed line and this point P is the fixed point. Now if we consider any point such that, let's assume that point is P1. If P of L1 equals to this P1 L1 equals to P1, that is this P1 equals to PL1, or if we consider another point P2 such that P2 L2 equals to P2, that is this. Similarly, PPN equals to this PN LN. Now if we trace out these points, the curve traced here is the parabola, just like this. Now here this fixed line is called as the directrix of this parabola, and the fixed point is called as the focus of this parabola. Now the para simply means for and bola means throwing. So that is, parabola is that shape described while throwing a ball in air. Now here this is the point P, which is the focus of this. If a line passes through the focus and perpendicular to the directrix, that is line L1 is passing through point P, that is point focus point, and it is perpendicular to the directrix, this line L1 is called as the axis of this parabola. The point where the parabola intersects the x-axis, that is here this point V is the point of intersection between this parabola and this axis. This point is called as the vertex. So simply we can say that L1 is the axis of this parabola, P is the focus. This vertical line here in this case is the directrix of this parabola, and V is the vertex of this parabola. Now we will derive the standard equations of this parabola. Now if vertex of the parabola is at origin, this means that the coordinate axes, that is x-axis or the y-axis, are considered as here, if vertex lies on origin, are considered as the axis of parabola. So this means there are four types of possible orientations. There are four possible orientations, that is, when this focus lies on x-axis on the positive side of x-axis, that is when this lies on the positive side of x-axis, that is point point F here is the focus, and it lies on the positive side of this x-axis, means its coordinates are a0. Now this means that here the vertex lies at origin, but here it is a parabola. So by definition, the distance of this origin from a fixed line, from this fixed point, that is from point F, should be equals to the distance of distance from a fixed line. So this means that we have to here consider the straight line, this x equals to minus a as the directrix. So this directrix is at the distance of minus a from this origin. Similarly, when this point focus point lies on y-axis but from the positive side, then we have to take y equals to minus a as it is directrix. Or if point F, that is focus, lies on the negative x-axis, this means that here in this case the possible orientation is just like this. Or similarly, if it lies on negative y-axis, now the possible orientation of such very parabola is like this. Now we will derive the equation of this very parabola, that is first case. Now let's assume that the focus lies on the x-axis This means that its coordinates positive x-axis. This means that its coordinates are a0. That is f equals to a0. Here the vertex is at origin. This means that the point of intersection between the axes of this parabola and this parabola is origin, that is 0 0. Here the coordinates of this are 0 0. It is a vertex. So this means that when this is a vertex, f is the focus. This means that the directrix of this parabola is at a distance of a units from the negative x-axis, from left side of the origin, which implies that we have to take x equals to minus a as the directrix. Now let p of xy be any point on the parabola, that is this point. So by the definition of this parabola, pm equals to pf. pm equals to pf. Here m is the point on this directrix, that is fixed line. Clearly the coordinates of p are xy because it is arbitrary point. Focus is a0, and m, which is the point on the directrix, which is at a distance of a units from the negative of 0. This means that its coordinates are minus ay. So using distance formula, pf equals to root of x minus y whole square plus y square. Pm equals to x plus a. So this means that from equation first, substituting pm and pf, x plus a equals to root of x minus a square plus y square, or squaring x plus a square equals to x minus a whole square plus y square. After simplifying this equation, we simply get y square is equal to 4ax, where a is positive. So this means that when point P lies on the parabola, then it satisfies this very equation, that is y square equals to 4ax. Now let's assume, hence any point on parabola satisfies y square equals to 4ax. Now conversely, let's assume that point P of any point, suppose P of xy, satisfies y square equals to 4ax. Then Pf, distance of this point from the focus, is, by using the distance formula, is simply given by x square plus a square plus 2ax, but in under root. So simply we can write x plus a. This x plus a is the distance between pm, that is pm, which implies that pf equals to pm. So this means that any point satisfying y square equals to 4x is such that the distance of this point from a fixed point and the fixed line are same. So by the definition of parabola, P lies on the parabola. Hence simply we can say that y square equals to 4ax is the standard equation or the form of this parabola where a is positive. When this is the parabola, its vertex is 0 0, its focus is a0 because it is positive, its directrix is x equals to minus a, or x plus a equals to 0. Now we have second, that is this very parabola. Here the focus lies on the negative x-axis. This means that its equation is y square equals to minus 4ax. Now similarly we can derive for this parabola, which is upwarded. Its equation is x square equals to 4ay, where a is positive, and this means that focus lies on the positive y-axis, and x square equals to minus 4ay is the equation or the form of this very parabola. Now here, if we consider this very parabola, this, now consider p of xy. P of xy is the point, and let us draw a line perpendicular on the x-axis through this point. When we draw a perpendicular through this, it cuts the point at this intersects the parabola at point P of xy and P dash of the coordinates of this point P are x comma minus y, So these are the coordinates of the point. Similarly, if we consider point here, suppose its coordinates are AB, then the point P of A minus B also lies on this parabola. So this means that whenever a point xy belongs, lies on the given curve, such that x minus y also lies or satisfies the given curve, then we simply say that this curve is symmetric along x-axis. So simply we can say that this very parabola is symmetric along x-axis, or if we consider the parabola of this type, this too is symmetric along x-axis. So we have two parabolas which are symmetric along x-axis. Similarly, we have two parabolas which are symmetric along y-axis. Symmetric along y-axis means that if xy, you know if xy is the point which satisfies the given curve or which lies on the given curve, in such a way that minus xy also lies on the given curve, then we say that it is symmetric along y-axis. So clearly we have two types, one symmetric along x-axis, and the equation of those parabolas are y square equals to 4ax and y square equals to minus 4ax, and x square equals to minus 4ay and x square equals to plus 4ay are the parabolas symmetric along y-axis. That is, this very parabola is symmetric along x-axis, this very parabola is symmetric along x-axis, while second and the fourth are the symmetric along y-axis. So inshallah in tomorrow's video lecture we will, you know do some problems on this, how to find, the equation of this parabola when given conditions, or when the constants are, or when the conditions are given. So thank you.